Hello, and welcome to the Astrolabe tutorial series. In this video, I will discuss how to access differential expression analysis reports for your experiment. This video will build on material presented in other tutorials. If you need a refresher, you can find links to tutorials about differential expression analysis setup and results below. As a reminder, for this demo, we are using a publicly available dataset from Glassberg et al., which used an ex vivo model to mimic the effects of thrombosis on a control and patient group with sickle cell disease. In experiment setup, we designed 3 differential expression analyses for each of the 3 time points at 10, 30, and 60 minutes. To access the reports, I'm going to click on Downloads and select Reports. Depending on the size of your experiment, this zip file may take a few minutes to download. I've skipped ahead a little so you can see what this looks like after I've decompressed the zip file. This folder contains the same data and visualizations we have been exploring in the Astrolabe application, and the folder structure here resembles the organization of the results in Astrolabe. For example, much of the data in the Cell Subset Navigator can be found in this folder for differential abundance analysis. For the purpose of this video, we are going to explore the Differential Expression Analysis folder. The information in this folder is hierarchical and is organized first by subset level. Because we explored the compartment level results in the previous tutorial, let's dig into this folder. If you are looking for more granular results, you will want to explore the assignment or profiling folders. When I set up differential expression analysis for this experiment, I created 3 analyses for the 10, 30, and 60-minute time points, and I can see files and folders here named for those defined analyses. Most of these results are a direct export of data that was presented to us in Astrolabe. So first, you may remember that when we clicked on the analysis results in Astrolabe, we were presented with a heat map that showed the fold change of each marker in each compartment. The files here represent that heat map. The JPEG is an image of the heat map, and the CSV is the data behind the heat map. If I go into the directories named for each analysis, you will see images for the heat maps and box and dot plots for each marker, as well as the data behind those visualizations. If I just look at extracts for CD57, I can see the data behind this heat map here. I can see a visualization of all box plots here, and a visualization of all dot plots here. Let's go back up a level and have another look at this file, which has the same name as the analysis I defined in Astrolabe. This may be what you are looking for if you want a comprehensive export of Astrolabe data. Since this is a CSV, I'm going to format it a bit so it's a little easier to read. The first column here is not meaningful in itself, but if I sort by it, I will see data organized first by compartment, then by marker. Subsequent columns give data for these parameters. This is a pretty simple demo experiment, but if I had an experiment with more dimensions, for example with multiple treatments, and I had set up pairwise differential expression analysis for those additional parameters, the max FC column would give me the max fold change across all those dimensions. Since this experiment really just compared patients to controls, the max FC matches the patient versus control fold change given in this column. Next, we have the p-value, and then the adjusted p-value, which in Astrolabe we also refer to as FDR. Again, here is the fold change of the patient versus control group. Had I defined more pairwise comparisons during setup though, I would see more columns representing fold change for those pairs here. The remaining columns represent the marker statistic I selected when I set up differential expression analysis. In this case, these are 95th quantile marker statistics, and they will line up with this heat map visualization in Astrolabe. This concludes our tutorial series on differential expression analysis. Remember, if you have any questions, you can always email us at support@astrolabediagnostics.com.